I'm Anil Kumar sharing with you question number 13 from Nelson Advanced Functions, chapter 6.2, Radian measure and angles on Cartesian plane. This is for my student Ryan, who wants to understand what are the possible angles and how do we have more than one answer for this question. Well, the question here is, you are given cos theta equals to minus 5 over 13, where theta is between 0 to 2 pi. In which quadrants could the terminal arm of theta lie? Determine all possible trigonometric ratios for theta. State all possible radian values of theta to the nearest 100. So that means there is definitely more than one value, right? Let's understand why do we have more than one value. What we are given here is cos of theta is equals to minus 5 over 13, right? So cos theta equals to minus 5 over 13. If you remember the cast rule, then you know cos is positive in two quadrants, but it is negative in two quadrants, right? So let me draw two different Cartesian planes here, since we do have two possible solutions for this. Now if you look into the cast rule, which says cos is positive in quadrant 4, all are positive in quadrant 1, sine in quadrant 2 and tan in quadrant 3. So what we get is that cos is negative in quadrant 3, 2 and 3, right? It is negative since the x value is negative, right? So x value is negative. Hypotenuse is the radius, which is going to be positive, right? So in this particular case, when we have minus 5 over 13, 5 is the x value, minus 5 I should say. So this is minus 5 for us, right? The x value. And 13 is the radius or the hypotenuse for this triangle. So let me just draw a dotted line to show you both the triangles. One I'm going to draw here in this quadrant. So here we have 13 radius, right? Now on this side I will take minus 5 as minus x value, and 13 I will take value in quadrant 3. So this is my 13. Perfect. So this is minus 5 and this side is 13, the hypotenuse. That gives us cos theta as negative. So when we are saying cos theta, we are always saying principal angle, correct? So the principal angle in this particular case will be from positive x-axis to this place, that is theta, right? In this case it is in quadrant 3. So that is theta for us. Let me call this angle as phi just to avoid the confusion, okay? So both are the same theta which we're trying to find, but we're just naming it differently. Okay, so what we notice here is that the quadrants could be either quadrant 2 or quadrant 3, since cos is negative, right? The x value is negative, r is always positive, so it has to be quadrant 2 or quadrant 3. Now the question is, determine all possible trigonometric ratios for theta. Now to find other ratios, what we can do is, we can find the y value, right? So y value will be 13 square minus 5 square. You could write minus 5 and then square it, square root, right? So that is, you can use the calculator, and square root 13 square minus 5 square equals to, gives you 12. So this value is 12. In this case it will be 12 positive side. Here it will be 12 but negative. That is to say the y value is minus 12 here and the y value is plus 12 in quadrant 1, right? Now we have a right triangle, right? So we can solve both of them side by side. We have a right triangle in which we know all the three sides. It says state all possible radian values of theta to the nearest 100. That's the last part. Before that, we need to determine all possible trigonometric ratios for theta. So let's write down all possible trigonometric ratios. When we say all possible trigonometric ratios, we mean what? We mean sine theta. So sine theta is for this opposite side. So you can look into the acute angle and then answer, right? Opposite to acute angle is 12. So sine theta will be 12 over 13. Cos theta, let me rewrite it. How does it matter? Minus 5 over 13. And tan theta will be minus y minus. It's the ratio of opposite to adjacent. Adjacent is negative 5. So 12 over 5 negative, right? Now the other three ratios are the secondary ratios, which are reciprocal of these. So sine theta reciprocal is cosecant theta. Let me write cosecant theta equals to 13 over 12. Secant theta for cos reciprocal will be negative 13 over 5. And cotangent theta is reciprocal of tan minus 5 over 12. So these are the 6 trigonometric ratios for the first case when theta is in quadrant 2. The terminal arm, I should say, is in quadrant 2. Now let's look into this. Here, sine theta is what? Sine theta is, we are in quadrant 3. Sine and cosine both will be negative, right? In this case, sine and cosecant were positive. Now sine is negative here. So sine is opposite side over hypotenuse. This is 12 over 13. Cos is given to us as minus 5 over 13. Tan is going to be positive in this case, right? So tan theta is 12 over 5. The reciprocal of these, that is cosecant theta, I'm using theta, I wrote 5, let me write theta, which is equal to 5, will be 13 over 12, but both are negative. I forgot to write negative, I'm sorry for that. And cos is sec theta, which is 5 over 13 negative, and tan is cotangent theta, which is 5 over 12, right? So that is how you can get all secondary angles. Now the last part is state all possible radian values of theta. So to find the radian value, what you should do is, you should find the acute angle, right? So I will first find the acute angle and then find the principal angle. So let's say alpha is my acute angle. So we'll use this particular equation. So alpha will be equals to tan inverse of 12 over 5. For example, we'll use a calculator now and we say tan inverse, which is shift tan inverse within bracket 12 over 5, right? So 12 divided by 5 bracket close gives me 1.176. 176. So that is acute angle, not the principal angle, right? Principal angle will be how much? In the first case, the principal angle will be acute 180 degrees minus acute angle, or pi minus acute angle, right? So for this case, let me write down here, theta will be equals to pi minus 1.176, right? We have to round it to 100. We can do this and then round. So let me do that. So say pi minus 1.176, which is equals to 1.965. So I can round this to 1.97. So this is in quadrant 2. This one is in quadrant 2. Perfect. In quadrant 3, theta is going to be pi plus 1.176. Do you see that? So let me add it now. So it's pi plus 1.176. That gives me 4.317, which is approximately 4.31. That is in quadrant 3, right? So that is how you can get the angles nearest to the hundreds, right? I hope this example helps you to get the basics, that if you know one of the trigonometric ratios, how you can find all others. And remember, if you're working in the domain of 0 to 2 pi, there are possibly two answers, right? Some values can give you three answers also. Let me give you a hint here. For example, sine wave can give you three zeros, right? Or the cosine wave, or for -1 there is only one answer. Do you see that? So there could be situations when you may not get two, you may get one or three answers also within this domain of 0 to 2 pi. But anyway, method is as we have discussed in this video, and I hope that helps you to solve most of the questions in this chapter. Thank you and all the best.